You are listening to The Vocal Technologist. Spoken tech for your ears.
Imagine your newest junior developer submitting 1,000 pull requests before they have even had their morning coffee, but also occasionally taking down the entire production environment. You would probably take away their keyboard, right? Well, you cannot really do that when the developer does not actually have hands.
Yeah, that is the core of the issue we are facing right now.
Exactly. So we're going to unpack a massive stack of industry research, server logs, and architectural diagrams to explore the chaotic reality of AI agent workflows. We want to look under the hood at how global infrastructure is, physically and structurally buckling under the weight of machine users.
It's an absolutely fascinating problem because we spent the last decade building systems exclusively for humans, and human traffic is predictable, right?
Right. Human typing speeds are finite.
Spot on. But the primary consumer of compute and infrastructure is rapidly becoming non-human. And, well, our current architecture simply was not designed to handle the sheer velocity of it.
Right, so let us pull apart the real-world fallout of this. We are seeing a massive code collision happening right across the industry. For example, Amazon is now forcing their senior engineers to manually sign off on AI-assisted changes.
Which is a huge operational shift.
It is, and this is not just a polite class suggestion. This comes after a series of major outages linked directly to AI-generated code.
Yeah, the underlying issue here is just the sheer volume of code being produced. When you have these autonomous agents or highly aggressive autocomplete tools writing entire modules in seconds, it creates a massive pull request validation bottleneck.
The human reviewers are just completely drowning.
Exactly. An AI can generate 1,000 lines of code that looks syntactically perfect. It compiles, but it contains subtle structural flaws or hallucinations.
Which takes a senior engineer hours of cognitive load to unravel.
Spot on.
Which is genuinely amusing, honestly. I mean,
Yeah.
We invented AI to save time, only to spend all our time reviewing its mistakes, because apparently that is where we are.
It is incredibly ironic.
It feels like taking a local post office and suddenly asking them to process global freight logistics. The building is the same, the staff is the same, but the sheer volume and weight of the packages are just crushing the foundation.
That post office analogy is incredibly accurate. And to handle those freight logistics, companies are having to fundamentally rebuild their core infrastructure from the ground up.
Right.
Take Airtable as a prime example. They executed a massive database rebuild, moving their core in-memory database entirely from TypeScript to Rust.
Which is not a trivial undertaking for a system managing enterprise data. I mean, why Rust? If the post office is overwhelmed, why not just throw more servers at the TypeScript architecture? Build a bigger post office.
Because you hit the physical limits of the runtime environment itself. Node has inherent limitations around multi-threading. It uses a single-threaded event loop.
Okay, right.
Think of it like a single-lane road. It is fantastic for input and output tasks, like fetching a web page, but it is terrible for CPU-bound workloads.
And enterprise AI automation is intensely CPU-bound, meaning the machine is doing heavy mathematical lifting, not just waiting for a network response.
Right. AI agents require rapid, complex data transformations. They are parsing massive JSON files, rewriting abstract syntax trees, running local validation loops.
And that single-lane road just gets completely deadlocked.
Spot on. Rust, on the other hand, enables safe shared memory parallelism. It allows the database to process multiple heavy queries simultaneously across multiple cores.
Like opening up a 10-lane superhighway.
Precisely. And doing it without the memory corruption risks that usually plague concurrent programming.
Okay, so we are essentially ripping out the engine while the car is driving down the highway, just so the machine users have enough horsepower to do their jobs.
Pretty much, yeah.
But this hardware bottleneck is really just a reflection of how we build systems in general. We try to lock things down for safety. We do the exact same thing to our human developers with the platforms we build for them.
Oh, absolutely.
You hear a lot about internal developer platforms or IDPs, but the success rate for those is absolutely abysmal.
It is roughly an 80% failure rate for these internal developer platforms. The industry calls it the golden cage syndrome.
Right.
Platform engineering teams build these incredibly expensive, comprehensive systems designed for strict control and compliance. They want everything standardized, but they completely ignore the actual developer experience.
So they build the cage. It might be painted gold, have a nice user interface, but it is still fundamentally a cage.
Precisely. They force human engineers into rigid abstractions. If a developer needs a slightly different database configuration for a new project and the platform does not explicitly support it, they are stuck.
So what do smart engineers do?
They actively avoid the platform. They find escape patches, write custom bash scripts, or they just go straight to the cloud provider with a corporate credit card.
Completely defeating the purpose of the platform in the first place.
Yeah.
But hang on, I really want to push back on this a bit. If human developers, who theoretically have common sense, hate these rigid platforms and actively look for escape hatches, how on earth are we supposed to build guardrails for AI agents that act completely autonomously? Like, if we cannot contain humans, how do we contain the machines?
That is a brilliant point, and it is the exact problem OpenAI is trying to solve with the launch of their Responses API. They are taking a completely different approach.
Okay, how so?
Instead of building a rigid golden cage, they are giving models like GPT 5.2 a full computer environment. We are talking about an isolated container with a fully functioning Unix shell.
Wait, really? They're just handing an AI a Unix shell. Giving a machine the ability to execute terminal commands autonomously sounds incredibly risky.
It is highly risky, which is why the containment strategy is so critical. The environment has domain-scoped network access with egress proxies.
Okay, let us break that down for anyone who has not dealt with egress traffic. What is an egress proxy actually doing here?
Think of the egress proxy like a highly suspicious customs agent at an airport. The AI can reach out to the internet to download a specific Python package or read API documentation.
Right.
But the egress proxy actively inspects that outbound traffic payload in real time to ensure the agent is not exfiltrating proprietary company code.
Or secretly launching a denial of service attack on a third-party server.
Exactly.
It is like handing a toddler the keys to a high-performance sports car, but putting them on a completely closed track so they can crash safely. You give them all the power, but you strictly bound the blast radius.
That is a great analogy. You give them the tools to do the work, but limit the damage they can cause. And it is not just OpenAI doing this. We are seeing the rise of orchestrated agent networks.
Right, like Docker Agent.
Yes, Docker launched Docker Agent, an open source tool that builds entire teams of specialized AI agents. You do not just have one generic AI. You have a product management agent, a coding agent, a QA agent.
All running in secure, isolated micro VMs.
Spot on. They collaborate, hand off tasks, and validate each other's work within this secure boundary.
That is wild. And we are already seeing this applied in the real world. I was looking at the Uber USpec example from the research. They connected an AI agent running inside Cursor directly to Figma.
Oh yeah, that is a fantastic example.
And this is not just the AI looking at a screenshot. This agent literally parses the underlying JSON node structure of the Figma file, calculates the pixel distances, maps those to CSS Flexbox properties, and automates entire design specs in minutes.
Work that used to take a human design systems team weeks is just done.
Exactly.
And that level of automation is exactly why the global infrastructure is buckling. When you connect local container sandboxes to these massive continuous workflows, it puts an unprecedented strain on global networks.
Right.
The LLM providers themselves, like OpenAI and Anthropic, are suffering severe uptime issues.
And to be clear, that is not because their code is faulty or they pushed a bad update, right?
Correct. It is simply because the rapid adoption is creating unpredictable surges that overload systems faster than they can physically scale server capacity. We are talking about automated scripts triggering thousands of complex reasoning tasks simultaneously.
It is a complete scaling nightmare. There is survey data showing 87% of executives expect container use to grow specifically because of AI. Yet, at the exact same time, 82% of them admit their infrastructure is totally unprepared.
It is a massive disconnect.
Yeah, they are dealing with shadow AI risks, massive organizational silos, and rising virtualization costs that are blowing up their cloud budgets. If you are managing a tech budget right now, this is the part where you should be sweating.
Absolutely.
So the obvious question here is, who is actually paying to keep the lights on for all these agents?
Well, the massive cloud providers are footing the bill, but they are doing it incredibly strategically. We are seeing a monumental $110 billion multi-cloud deal involving OpenAI and AWS.
$110 billion. That is just staggering.
It is. OpenAI expanded its AWS spending by $100 billion specifically to give AWS exclusive distribution of the frontier stateful AI runtime.
Okay.
Meanwhile, Azure retains exclusive stateless API access.
Right, we need to unpack that. because stateful versus stateless is a massive structural shift in cloud computing.
Yeah.
I think a lot of people gloss over what that actually means for the physical hardware racks sitting in a data center.
Oh, it changes everything about how data centers are built and cooled. A stateless API call is what we are generally used to. You send a prompt, the server calculates the response, sends it back, and immediately forgets you exist.
It has goldfish memory.
Exactly. It is highly efficient and easy to scale horizontally because any server in the cluster can handle the next request. Azure's keeping that highly profitable workload.
Right. In and out, no memory required. The server does not need to care who you are once the transaction is done.
But an autonomous agent needs to be stateful. It needs elephant memory. If Docker Agent is spinning up a team of AI product managers and developers working on a code base for 3 days, those agents need persistent memory.
They need a stateful runtime that remembers the context of the conversation.
Yes, and holds the file system changes in memory and maintains the open network connections.
Which means tying up a dedicated server rack for days at a time.
Precisely. AWS securing the exclusive rights to that stateful infrastructure means they are betting that the future of compute is not just quick API queries, but long-running persistent machine users effectively living in the cloud. They are building habitats for digital workers.
Which means the network layer itself has to adapt to a world where the vast majority of traffic might soon be machine-to-machine. We are not just serving up streaming video to human eyeballs anymore.
Spot on. And the open source community is scrambling to build the underlying plumbing for this. Kubernetes has literally launched an AI gateway working group. Their sole mandate is to develop entirely new networking infrastructure standards specifically for AI workloads.
Because the old rules just do not apply anymore. It is like treating human web traffic like regular passenger flights. They arrive on a schedule, they follow standard routes, they have a known destination, and you can manage them with standard air traffic control.
Exactly.
But agent traffic is an endless swarm of automated delivery drones. They are erratic, they operate at a completely different speed, they might suddenly spawn 50 sub-drones mid-flight to scrape a database, and they need entirely new air traffic control rules to stop them from crashing into each other.
That drone swarm analogy perfectly captures the chaos facing network engineers. If your network layer is built for passenger flights, the airspace simply collapses under a drone swarm.
Right.
The Kubernetes working group is focusing heavily on payload processing inspection and prompt filtering across clusters.
How does that actually work in practice?
Well, when an agent sends a payload, the network needs to physically inspect it in real time to ensure it does not contain a malicious prompt injection before it ever reaches the highly expensive inference engine.
Ah, so you want to drop the bad packets at the edge, not after you've already spent compute power processing them.
Exactly. And we are seeing the big edge networks adapting to this drone swarm too. Cloudflare rolled out structured error responses, which honestly is one of those brilliant invisible engineering fixes that just makes perfect sense when you think about it.
It really is elegant. Historically, if an API endpoint failed or timed out, the server would return a standard HTML error page. Think of a 500 internal server error page.
Right.
A human looks at it, sees the big bold text, and hits refresh. But an AI agent cannot just glance at it.
No, the agent reads that entire HTML document, processing every single formatting tag, every inline CSS style, which consumes a massive amount of token bandwidth and compute power, only to fail to understand what actually went wrong.
It is a complete waste of bandwidth. You are forcing a machine to read human formatting. So what did Cloudflare do to fix it?
They automatically implemented RFC 9457 compliant structured Markdown and JSON error responses for AI agents. So instead of a bulky web page, the agent gets a tiny machine-readable JSON payload.
Oh, wow.
It cuts the payload size and the token usage by over 98%.
So instead of hundreds of tokens of HTML, it is just a 10-token data structure saying error equals rate limited.
Exactly. And more importantly, it gives the agent direct programmatic instructions on retry timing. It literally tells the machine in a language it understands, back off for 30 seconds and try again.
That is just phenomenal engineering. Stop treating the machine like a human web browser. And Cloudflare is pushing further into that space to protect the infrastructure, right? They made their AI security for apps generally available.
Yes, and it ties directly back to that prompt filtering the Kubernetes group is working on. Cloudflare is putting the protection at the edge network to stop prompt injection and data leaks before they even hit the cloud provider. Right.
And Going back to the very beginning of our conversation about that massive flood of AI-generated pull requests taking down production, teams are now heavily relying on Istio-ephemeral environments to manage that specific bottleneck.
Wait, I am losing the thread here. If the AI is generating 1,000 pull requests, how does adding Istio into the mix actually save the human reviewer any time? Aren't they still looking at 1,000 code changes?
No, because they are automating the validation.
Hmm.
Istio allows platform teams to spin up extremely lightweight, temporary sandbox environments for every single service change.
Oh, okay.
We're basically talking about spinning up a disposable parallel universe of your application.
A parallel universe just for testing.
Exactly. Because Istio handles all the complex traffic routing natively, you can let an AI agent generate 1,000 code changes, spin up 1,000 ephemeral parallel universes, run the automated integration tests against the real database schema, and then tear all those universes down in minutes.
That is incredible. It is the only way to efficiently validate code at an agentic scale. You let the AI test its own work in a secure bubble, so human engineers do not have to manually review every single line.
It is genuinely incredible how all these individual pieces connect into one massive shift. We have agents writing so much code that human reviewers are drowning, so we build micro VMs and responses APIs to safely sandbox them.
Exactly.
The cloud providers fundamentally split their infrastructure between stateless queries and stateful agent habitats to handle the physical memory load. And the network layer rewrites its basic error codes just so these machines can talk to each other without burning through billions of unnecessary tokens.
Spot on. It is a complete architectural rebuild of the internet, happening silently in the background, specifically tailored for non-human users.
Which leaves you with a rather unsettling thought. We started by talking about human engineers actively escaping the rigid golden cages of their internal developer platforms because they hate the constraints. But as we hand over more of this architectural rebuild to the machines, what happens when these autonomous AI agents start running their own developer platforms? Will they build themselves the exact same golden cages that human engineers despise? Or will they create something we cannot even comprehend? Something for you to mull over next time your code failed to compile. Keep exploring. I am the vocal technologist, and we will catch you next time.
Spoken Tech for your ears.